Okay, welcome to the lesson 4 video. We're going to continue graphing quadratic equations here in factored form. So you can see here that after our discussion today, you should be well aware of how these graphs are formed. And the first thing you should always look at is what the leading coefficient is. So if you look over here on the side, we have an equation y equals 1/2 x plus 3 times x minus 4. And the leading coefficient here is positive 1/2. So since it's positive, this one is going to open up like a cup. And then since 1/2 is relatively close to 0, and what I mean by that, it's less than 1 away from 0. So if I draw a number line, and here's 0, and I have -1 on this side here, +1 on this side here, anything inside of this window between -1 and +1 will make a very wide parabola. So right in this area, this spot here will make wide parabolas, and if it's on the other side of 1 or -1, the pink area, that will make very narrow parabolas. Now because 1/2, positive 1/2, would be right around here, then this is going to be a wide parabola. So I'm just going to write that underneath. I know that this is going to be a wide parabola because, again, just like you saw in our class exercises, that it gets closer to 0, it gets wider. We also learned in class that in order to find the zeros or the x-intercepts, I need to first factor my equation. And this one, luckily for us, is already factored. And I need to set this equation equal to 0, that is to make y 0. And once I do that, I can take every factor, and because it's set equal to 0, I can use the zero product property, which means that if I have a bunch of stuff that multiplies together to get 0, then one of these things has to be 0. Now 1/2 cannot be 0. Okay, 1/2 is not 0. It's 1/2. But x plus 3 and x minus 4, depending on what x is, could be 0. So what I do to find the zeros, I actually set those factors, x plus 3 equal to 0, and the other factor, x minus 4 equal to 0. Now you must subtract both sides on this one using inverse operations to solve for x. So x would have to equal -3. And on this side, I use inverse operations, which means I'm going to add 4, and I will solve for x over here. So x can either be -3 or x could be positive 4. When I write my zeros, I'm going to write them as ordered pairs, which means I have -3, 0, and positive 4, 0. Well, why do I know that the other coordinate is 0? Well, that's because when I put in these values for x, my y value becomes 0. That was the whole design of this experiment here, that I needed to make sure that one side of my equation was set equal to 0. Because I want x-intercepts, the y has to be 0. Because the y is 0, one of these factors equals 0, and I found the x values that makes that true. So now I have the x-intercepts, or the zeros. Now I need to find the axis of symmetry. Well, the axis of symmetry should be right in the middle between -3 and 4. And in class today, I showed you two methods to find it. You either add -3 and positive 4 together and divide by 2, and I would get 1/2. Or you could just visualize on a number line. So if I have 0 in the middle here, and I have 1, 2, 3, that's -3. And on the right side, I have 1, 2, 3, 4. How many apart are these? 7. 1, 2, 3, 1, 2, 3, 4. They're 7 apart, and right in the very middle would be the axis of symmetry. It has to be right in the middle here between those two. And there's an equal spot on the left side as there is on the right side. And so I know that my axis of symmetry has to be x equals positive 1/2. Because that's right in the middle. X equals 1/2 would be that imaginary line that goes up and down. And from class today, you know that the vertex has to, the axis of symmetry has to pass through the vertex. So the x value I got for the axis of symmetry for finding the middle between my two zeros has to be the x value of the vertex. How do I find the y value? X and y. To find the y value, I plug it into my equation that tells me what y is. So I'm going to go ahead and do that. I'm going to be kind of running short on space down here, so I'm going to do it right at the bottom. I'm going to change my color to green. So I have 1/2, so y equals 1/2, and I got 1/2 again for my vertex value for x plus 3. Now do you see what I'm doing? I'm taking the x value from the axis of symmetry and I'm plugging it in to this equation over here for x. And you should see quickly that I'll get 1/2. This is going to be 3.5 or 3.5, and this is going to be -3.5. I have to multiply those together, and so I'm just going to do that with my calculator here, so one moment. Now you see I've popped up a calculator. So my first part was 1/2, so I'm going to do 1 divided by 2. Okay, that's 1/2, 0.5 times, and I want 3.5 times negative 3.5. So 3.5, I'm going to make it negative. My answer is 6.125, negative 6 and 1.125, which is negative 6 and 1/8. Let's go back to my video here. So I know it's going to be, when I put in 1/2, it's going to be negative 6 and 1/8. Let's start to graph some of the stuff that we know already. So I have a blank coordinate axis here. I'm going to make my x-axis right over here. All right, right over there. Make my y-axis up and down over here. That was bad. I kind of got squiggly at the end. That's okay. So now I'm going to make my axis go by ones here. 1, 2, 3, 4, 5. I'm going to make my y-axis go by the same one. So 1, 2, 3, 4, 5. That's negative 5 right there. And so let's plot my vertex here. That's going to be at the point 1/2, negative 6 and an 1/8. I forgot to switch that up. It should be 1/8 there. My mistake. So I have 1/2, which would be right here, and negative 6 and 1/8. 1/8 is going to be really close to that negative 6 there, so it's going to be right there. Okay? Now my axis of symmetry has to go through that point. I'm going to make that pink, because that's what I did before. So there, here's my axis of symmetry. It has to go right through that vertex, just like so. Now, let's plot the ordered pairs that make up my zeros. Negative 3, 0. So that'd be 1, 2, 3, negative 3, 0. That's one x-intercept right over there. And 4, 0 is the other one. Now you can see that this parabola was supposed to be up and wide, kind of like this. Does that look right based on what I'm doing? I think so. Now to finish this problem off, I need to add 1 or 2 more points to make my U-shape. Again, that U-shape called a, you guessed it, parabola. Don't forget that word. It's called a parabola. Okay, so let's go through here now again. And so I'm going to plot a point. I want to get some more points in here. So I'm just going to choose an x value, and I'm going to choose maybe 2. Let's choose 2 for x. To get what y equals, I plug it into this equation for x. So I have 2 in here and 2 in there. 2 plus 3, 5. 2 minus 4, negative 2. What does that get when I multiply it together? 5 times negative 2 is negative 10. Divided by 2 is negative 5. So at positive 2, I go to negative 5 here, and it looks like it's getting wide, right? You could sort of see that U shape coming into play if you follow my cursor there. Now, because this is called the axis of symmetry, if I measure the number of boxes to my point to the axis of symmetry, which is 1, 2, 3 boxes, if I go the same number to the other side, 1, 2, 3, there should be another point over there, which has the coordinates negative 1, negative 5. And you could verify this by plugging in negative 1 in for x. So I'm going to erase what my work was over here for the negative 2, putting 2 in there. I'm going to put a negative 1 in for x. So I have negative 1, negative 1. What's negative 1 plus 3? Well, that's like 3 minus 1. That's 2. Negative 1 minus 4 more, negative 5. And you see I get the same combination. 2 and negative 5 makes negative 10. Divided by 2 is negative 5. And now you can definitely see the U shape. Now for full credit, make sure you don't skip drawing this. It should look like a U. Don't make little weird ends here. So it should go up nice and smooth like that. It might take some practice to get used to this. It took me a long time to be able to draw these well. I'm a math teacher, so I have to do it a lot. So that's why mine has this nice little U to it. You might need to practice a little bit. Let's do another one. A science class designed a ball launcher and tested it by shooting a tennis ball straight up from the top of a 15-story building. They determined that the motion of the ball could be described by the function h of t equals negative 16t squared plus 144t plus 160, where t represents the time the ball is in the air in seconds, and y represents the height in feet of the ball above the ground at time t. So what is the maximum height of the ball is what we might want to know about this, and maybe we might want to know what time will the ball hit the ground. Well, this equation, h of t, doesn't really look anything like this equation over here. That's because we have not factored it yet, and h of t is not y. Why don't we just change that to y to make it easy? Now, we need to factor the right side of this equation, and you should remember the 3 steps of factoring. I should look for what first? You should be yelling at your screen. Greatest common factor, right? What goes into all these numbers? Well, 16, 160. I know 16 goes into both of those. Does 16 go into 144? Let's check. 144 divided by 16. 9, sure does. So we're in luck. We could take out a 16 from here. Now note, do you notice this is negative 16? Let's use negative 16 and just take that out. Because then my first term, negative 16t divided by negative 16 would be positive t squared. We just saw in our calculator that 144 divided by 16 was 9. If I use negative 16, it would be negative 9t. Again, what I just did there was 144 divided by the greatest common factor, negative 16, equals negative 9. 160 divided by 16 is 10, and since it's a negative 16, it will be negative 10. So I found the greatest common factor. Now the second step is looking for a special case. Do I have one? Is it any perfect squares? Nope. The first one is, but 10 is not. So then I try to factor it. So the factored version then equals negative 16, and now I have to find something that will multiply to be negative 10 and add to be negative 9. Well, I'll save you some work here. It's going to be t minus 10 and t plus 1. Check. Negative 10t, positive 1, that makes negative 9. Negative 10 times a positive 1, negative 10, t times t, t squared. Okay, good. Now, which way is this one going to open? Let's go back to what we just learned. How do we know which way it's going to open? I look at the a value, okay? Positive or negative. It's going to open down, wide or narrow. Well, 16 is really far away from 0 to the left, so it's going to be opening down and really tall and narrow like this. So it's going to look like that when we're done. Now it's asking the maximum height of the ball. What point do we ascribe as the maximum or minimum value of a parabola? The vertex. In order to find the vertex, I need to find the axis of symmetry, and in order to find the axis of symmetry, I need to find the zeros. So this problem that had nothing really to do with my last problem is actually really similar to it without saying the same stuff. In other words, I had to learn what I learned in the previous slide to solve this problem. What is the maximum height of the ball? I talked about this in class. These are way more interesting questions. I want to know about something in the real world. So we need to find the zeros, or the x-intercepts. Well, now that I have my equation in factored form, I can set these factors equal to 0 to find the x-intercept. Y would have to be 0. So I have negative 16, t minus 10, t plus 1. So then I set these factors equal to 0. I know that t has to be equal to 10 by adding 10 to both sides. I should just show you that work there because I'm not doing my own example. Don't just switch the sign. Make sure you actually set it equal to 0 and solve. T equals 10, and then this one t plus 1 equals 0, so t equals negative 1. Now t can't be negative 1. Why not? T represents time, so t can't be negative 1, so t has to be 10. But if I were to graph this thing, I'm going to start way down here because I know that 0 height would be the ground. There's x. I'm going to just go ahead and make my y-axis here. And I'm going to make every box worth just 1 here. Okay, so I'm just going to go by ones. 1, 2, 3. So 1, 2, 3, 4, 5. There's 5. And then 10 would be here, and so on. So no, I should have an x-intercept at negative 1. So I'm going to graph that in blue. Negative 1 and positive 10. Those are my two zeros because that's what I just found, the values of t that would work. So my x-intercepts are 10, 0. And negative 1, 0. Okay? Now I need to find the axis of symmetry to find the vertex. Because again, my goal is to find the maximum height. I want to find the vertex. So the axis of symmetry should be halfway between negative 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 boxes between. What's half of 11? It should be 5.5. Now I'm measuring 5.5 from the end. So 1, 2, 3, 4, 5.5. Should be right there as the axis of symmetry at 4.5. Now if you didn't follow my math there, what I did is I averaged out my numbers. I took positive 10, which is the first x-intercept, plus negative 1, which is the second y-intercept, and I divided by 2. I got x equals 4.5. So to get the maximum height, I have to plug 4.5 into this equation. Now I'm running a little short on time, so I'm going to plug that in when I pause the video, and I'll show you the work in just a minute here. So down here in pink is my work. Down there in pink is my work. I put 4.5 in for x, and after doing a bunch of math and plugging it into my equation for y, I found out the maximum height of the ball would be 484 feet. Now I obviously don't have 484 squares, so I could remedy this by making my scale go by maybe 25s. So I'm going to label that quick. So now you see my y-axis is going by 25s per block up to 400, and then my vertex is up here. So now I found the maximum height of this ball. And this is the path the ball is going to fly on, roughly like that. We'll talk more in class about this tomorrow.